Hello students, I hope you are good, well and fine, and today we will be discussing about probability. So let's see probability and what we use probability for. We use it for predictions or or to know possibilities of having some events. Okay, you will see what do we mean by events. So let's begin our topic. So theory of probability deals with measurement of uncertainty, means possibility of the occurrence of same event or incident in terms of percentage or ratio. Okay, so let's see some terminologies such as sample space, trial. So what do we mean by sample space? First of all, so sample space is the set of possible outcomes. For example, if you are tossing a coin, then what will be your outcome? Tossing a coin. So outcomes either head or tail. Okay, so this is my sample space, just possible outcomes. Okay, now what is trial? Trial is an action which results in one of several events. So trial means it is an action which result one of several events, several outcomes. So our outcomes are this one and this one. So trial meaning each one of this will happen, either a head comes or either tail comes. I hope this is also clear. Let's move to next. Now, what do we mean by an experiment? An experiment is kind of activity such as throwing a dice, a coin, tossing a coin, drawing a card, and etc. Okay, so this is any kind of action such as throwing a dice, tossing a coin, etc. So for example, in previous we tossed a coin. In outcomes or the sample space was head and tail. On throwing a dice, you will either get 1 dot or 2 dot or 3 dot or 4, 5, 6 can occur. So this will be my sample space. So sample space for dice, throwing a dice okay, is 1, 2, 3, 4, 5, 6. So this is my sample space. This is my whole experiment. Okay, an event, what do we mean by an event? Event means if getting a 6 in a throw of dice is our event, getting a head in tossing a coin is also our event. So these individual elements of the outcomes, we call it as an event. So this event occurs, that means we are saying if 6 occurs, that means when we throw a dice, the event 6 is occurs. That means the 6 dots will appear on top of that die. Okay, so let's move to next. See more terminologies. So fifth one is a random experiment. So random experiment is whenever we do some experiment at once. Okay, so suppose we are doing experiments at once, different experiments. So we say we are doing a random experiment. For example, tossing a coin and with if you say tossing a coin with playing cards. Okay, so as you toss a coin, you draw a card. Or you can take another example, just throwing a dice and then you toss the coin. Okay, so these are the examples for a random experiment. Now the sixth term is equally likely outcome. So equally likely outcomes, as the name suggests, equally likely outcomes. So from the sample space, an event, if all the individual events are having the same possible outcomes. Okay, that means for example, if I throw a die and I am either getting 1, 2, 3, 4, 5 or 6, so throwing a single die I am getting this, and picking anything will give me a equally likely chance to get a number. So this we called equally likely outcome. So any of this number 1 to 6 can occur with equal having with equal chances. Okay, so this means equally likely outcomes. Now this point, the probability of an event A, we write it as P of A. That means we defined P of A, or the probability of an event A is a number of outcomes in favor of A divided by total number of possible outcomes. So this means total number of possible outcomes. That means the number of number of elements in sample space. I hope this is clear, and this means the number of outcomes in favor of A. That means if you see from an example, say tossing a coin, you will get either head or tail. So this is my sample space, sample space, which is equals to head or tail. Or if I am finding the probability for head, and my event is now head, that probability of occurring head is equals to, as head occurs only, this is the number of outcomes in favor of H. So the number of outcomes is just 1 divided by the total number of possibilities. So the total number of possibilities are 2. So this will be my probability of getting head. Okay, so I hope you understood from this example. So let's move next. Let's see some important properties. Always do remember that a probability is not always be greater than or equal to 0, but less than or equal to 1. It always lie in between 0 and 1, and can take a value 1 also or 0 also. I hope you are understanding it. And this means if probability is 0, that means this event A is not going to happen. That means probability is 0. For example, if you say that if someone is tossing a coin, the sample space is head and tail. If you say the probability of getting head tail at the same time, so this will not occur. So this means the probability is 0. Okay, and what if we say the probability of A is equals to 1? That means that this event A is going to happen on always. So no matter what the conditions are, this will always occur. For example, in this case, probability of getting either H or tail, so this always be my 1, because whatever I'll do, I am either getting head or just tail. So this is what the probability or this is what the event asking me for, the probability of getting H or T. Whenever you toss a coin, you will either get head or you will get either tail. So this is 1. I hope this is clear to you. Now in the second property, it says probability of an event which is not happening of A, that means A is not happening, plus probability of A is happening is equals to 1. That means what we are saying, that a probability of an event happening is plus probability of an event not happening, this will add up to 1. Okay, so let's see from our example. If you say the if you add these two, so probability of getting head tail both and probability of getting either head or tail, if you add both of them, what sorry, this is not let's see this example. So probability of getting say probability of getting head, okay, and now uh, probability of not getting head, okay, not getting head. So if you see, so probability of getting head is 1 by 2, we already know. Probability of not getting head, that means we are asking for probability of getting tail. So yes, we are asked here indirectly that the probability of getting tail in this case. So probability of getting tail is the favorable number of favorable outcomes of an event which is only just 1, and the total number of events in a sample space is 2. So this is also our half. So half plus half, we get 1. So you verified that this property is also holds. Now probability of not happening of an event A, we write it as in mathematical terms P of A bar. This means not happening of an event A plus P of A, which equals to always 1. And in other words, we say probability of an event not happening is equals to 1 minus probability of happening of an event A. I hope these two properties are clear to you. Let's move next. Now, probability of the happening of A, that means number of favorable outcomes divided by total number possible outcomes, as we saw in the previous example of tossing a single coin. Tossing a single coin. So here it is equals to m plus divided by m plus n, where m is our, what is our m? M is the number in which A can happen. So an event A can happen in m ways. So the number of favorable outcomes is m, and total number is m plus n. So and what if we are asked to probability of not happening of A, this means the n divided by m plus n. So whereas n is our event A of failing, so in n ways my event A will fail, that means not going to happen. So this means n divided by m plus n. So in total happening A can happen in this way and A going to fail in this way. So total number of outcomes will be m plus n. That's why we used our formula for probability to find out the probability of happening A and not happening of A. I hope this is all clear to you. Let's move to next. Now problem of a die. So let's see, first a die is thrown once. Okay, what is the probability of we are given an event A So we have to find out the probability of an event A, and what is our event A is getting an even number in the throwing of a die. Okay, we know our sample space will look like this: 1 to all the possible outcomes, which will be 1 2 3 4 5 and 6. Okay, now what is my event A is getting even numbers, which will be what will be my even numbers. So 2 4 and 6. So if you see, I have total numbers which is 6, and the number of favorable terms which is 3. So it is 3. So my probability of an event A getting even numbers will be equals to 3 by 6, which will be 1 by 2. I hope this is clear. So as it is given here, the total number of outcomes is 6. Let be the event of getting an even number, then there are 3 even numbers: 2 4 6. The number of favorable outcomes is also 6. And the probability of getting that event is number of favorable outcomes, which is 3 divided by total number of outcomes, which is 6. So it will be 1 by 2. The spelling mistakes is here, so please do correct the favorable okay, favorable outcomes. Okay, let's move next. I hope you understood. Okay, now total outcomes was 6. Yes, now my event B is given. Now I am asking for probability of getting an odd number. Okay, so this will be my B, not event A. Now event B is getting an odd number. Event B is my getting an odd number. Okay, now the total favorable outcomes is equals to 3, which are those. So odd numbers are 1 3 and 5. So in total these are 3 numbers. So favorable outcomes are 3, total numbers of outcomes is equals to 6. That means the probability of getting an odd number is equals to 3 by 6 or 1 by 2. Okay, let's move to the C event, getting a natural number. So this will be probability of C. So the event C is getting a natural number, which is, so my total outcomes still remains the 6. And if you see the favorable outcomes, so in favorable outcomes I will list all the natural numbers out of the total or the sample space. So the natural numbers will be 1 2 3 4 5 6. All of the elements from the sample space will lie in this set of natural numbers. So my total number of favorable outcomes will also equals to 6. So this means 6 divided by 6. I hope this is equal. So the probability of getting a natural number is equals to 1. Okay, now for D, my probability of getting a number which is multiple of 2 and 3. So favorable outcomes will be multiple of 2 and 3, which is my just 6. So the final or the elements in this must be a multiple of 2 as well as 3. So 2 is a multiple of 2 but not 3. Okay, same with 3, same with 4, same with 5. 5 is not multiple of any of the number, and with 1 also. So the only number remaining is 6, and yes, indeed, the 6 is the multiple of 2 as well as 3. So our final answer will be 1 by 6. Okay, so the favorable cases, or the favorable, is just only one number, 6. So 1 by 6. I hope this is all clear. Now now for this, the event E of getting a number greater than 3. So what are the number greater than or equal to 3? 3, 4, 5, 6. So the favorable outcomes are 4. Okay, so favorable outcomes are 4. So total number of favorable outcomes divided by total number in sample space, which is 6. So 2 by 6 is will be my probability of getting a number greater than equal to 3. And for this event, getting a number 5 or 6, okay, so probability of getting an event, my event is getting a number 5 or 6. So either I'm going to get 5 or 6. So in favorable outcome, the total number will be 2, and this remains 6. So 1 by 3. Now for event for event G, the event says the getting a number less than equal to 5. So my probability of G, what will be? So if you see the favorable outcomes, will be my 1, 2, 3, 4, 5, all the numbers less than or equal to 5. So this set containing 5 elements, so this means total number of favorable elements is 5 divided by total number of elements in sample space, which is 5 by 6. So this will be my probability of getting a number less than equal to 5. So, and here the favorable outcomes are written 1, 2, 3, 4, 5. I hope these all were all clear to you. I hope you understood what do we mean by probability, how do we get a probability of an event, and you saw many examples. So let's move to next. Now, probability concerning with drawing a card. First of all, sorry, let me give you a small or the brief intro to cards. So there are 52 total cards, okay, and 4 suits. What do we mean by suits is this, that 4 suits. One suit is my spade. Okay, say spade. One suit is my spade, which is of this. This is my spade. Okay, and a diamond, and a heart, and in the last the club. So club look like this. So club, my club. Okay, so club. So 4 suits: spade, diamond, heart, club. Each of them are in 13 numbers. So spades, in total 52 cards. 52 cards divided into 4 suits, and 4 suits is divided into 13 number of cards, which is we have 13 spades, 13 diamonds, and 13 hearts, and 13 clubs. I hope this is clear to you. And if you see, diamond is of red color, and heart is of also red color. Heart is already of red color if you can connect with human heart. So heart is of red color, and so is the diamond, and the remaining two are of black colors. Okay, so black color and black color. So in total we have 26 red cards and 26 black cards. 26 black cards. I hope this is all clear. Now face cards. Talk about face cards. So face cards are J or Jack, Queen or Q, Queen, J, Q, K or King. Okay, I hope this is clear. These all cards we called it them face cards. So Jack numbers are four cards there, four for Queen, and four for King. Okay, I hope this is all clear. And these four cards further uh, belongs to: one is spade, second is diamond, third is heart, and fourth is club. Same thing will happen here. Okay, and same goes for king. Each of the card is of spade, diamond, heart, and club. I hope this is all clear to you. And in total there are 12 face cards. So I hope you will remember these all theory about cards. Then you will answer the question based on cards probability. Okay, let's see our problem. So we already know a pack of 52 cards. We already know face cards. Now let's see an example. So a card is drawn from a well shuffled deck of 52 cards, and find the probability of a king. So getting a king. So how many kings, or the number of favorable outcomes of the kings are 4. We have 4 kings, and if you see we have 4 kings. If you recall, 4 kings by 52, this will be my probability. Hearts, how many hearts I have? How many hearts? So 13. So if you remember, heart is belonging to suits, and each suits contains 13 cards. So 13 by 52. I hope this is all clear. And 7 of hearts. So 7 of hearts, how many 7 of hearts I'll be getting? Only 1, because there are 4 cards of 7, and each of them will belongs to: one will be my of spade, okay, one will be my of diamond, one will be my of club, okay, and one will be my of heart. So only just 1 card. So 1 by 52. Okay, now a jack, a queen, or a king. So these all are face cards. In total I have 12 face card divided by 52. So the number of favorable for face cards are 12, and in total I have 52. Okay, so let's move. I hope this all are clear to you. Let's move to next. 2 of hearts or a 2 of diamond. So 2 of hearts means I have just 1 2 of hearts and 1 2 of diamond, just only this. So this means 2 by 52. And face cards, I have 13 face cards, sorry, the 12 face cards. If you recall, J, Q, K, each all are of 4 in number, so 12 face cards. Black card, we know black cards numbers are 26. Neither a heart nor a king, that means neither a heart. So neither a heart nor a king. So if you recall, heart numbers are what? 13 and kings are of 14 numbers. So and from this, kings can be of heart also, spade also, club also, heart, spade, club, and diamond also, diamond. Okay, so in 13 cards, this is also already belongs the heart card, because we already took neither a heart, that is this. So this means here we remaining with 3 only. So this will be the heart number is this. So 13 plus 3 will be my 16, and in total I have 52 cards. So the probability will be 16 by 52. Neither an ace nor a king. So in ace, ace has 4 cards, same with king. So 8 by 52. I hope these all are clear to you. Let's see the answers. So yes, king has 4 favorable cases. That means 4 by 52. Okay, a heart has 13 favorable cases. That is 13 divided by 52. 7 of hearts, that means only one card is of 7 of hearts, so 1 by 52. A jack, a queen, or a king, that means 12 face cards, 12 divided by 52. 2 of heart, 2 of hearts, or a 2 of diamond, that means, so 2 of hearts or 2 of diamond, that means just only one card we will get 2 of hearts, and only one card we will get 2 of diamond. So in total I have 2 favorable cases. So 2 by 52 face cards. In total 12 face cards are there. So 12 divided by 52. Now a black card, in total 26 cards belongs to the black card. So 26 divided by 52. Neither a heart nor a king, that means 13 hearts. We know we have 13 hearts, 4 king, but one is common, that is king is one king is of a spade, one king is of a diamond, one king is of a club, and one king is of a heart. So this will be our common. So I just 13 plus 4 minus 1, the common term. So this will be my 16. So 16. So we are asked for neither. Sorry, in previous I just gave you the probability of getting heart or a heart or a king. So probability of a heart or a king. So this means probability for a heart or a king is 52, and probability for neither a heart nor a king, if you recall, probability of an event happening is equals to 1 minus probability of the event not happening. I hope you are clear with this. So from this I can say the probability of not getting a heart nor getting a king is equals to 1 minus 16 by 52. This will give me 36 by 52. So at last, neither an ace nor a king, which means the 44 by 52, or we can say that 1 minus, so ace 4, king 4, that means 8. Okay, so this means 4 by 13. So 13 minus 13, so 4 times 2. So 4 times 2, 4 times 13. So 2 by 13, which will be 11 by 13. So yes, the probability for getting neither an ace nor a king will be 11 by 13. I hope all these are very clear to you. So I hope you understood from the theory very well. So we will be meeting next. So thank you for being here. Thank you. We will meet next time.